Hi, and today we're going to be solving derivatives using the power rule. Now, out of all the derivative rules, the power rule is probably the most simple one out of like the multiplication and product rules. Now, the way that the power rule works is that I'll just explain this right here. The derivative in respect to x of x to the n equals n times x to the n minus 1. Now, all you're doing here is just multiplying the n times the coefficient in the front, and then subtracting 1 from the exponent. Now, I'll show you how it works in practice. We have 3x squared plus 2x plus 4. Now, all you do is just multiply 2 times 3, and then subtract 1 from the exponent, which gives you 6x. And then you have plus 2 right here, and then the 4, due to the constant rule, cancels out. Now the 2 is actually 2 to the first, and then when you subtract 1, it becomes 2x to the 0, and anything to the 0 is 1. So you're just left with 2. So that's how simple that is. That's the derivative of 3x squared plus 2x plus 4. Now the next problem is just as simple as the other one. All you do is multiply 2 times 6, you get 12x plus 3, and then the 5, due to the constant rule, cancels out. See how it's just same, and then here the next one is just 15x to the x squared plus 4x plus 3. It's just 3 times 5 is 15, minus 1 is 2, and then the next one is just 2 times 2 is 4, minus 1 from the exponent is x, then plus 3. Once you do like a million of these, you can do them in basically a heartbeat. I mean, it's really simple. All it takes is just remembering the rule. Now, for the next one, it's just slightly longer. You have 40x to the third plus 18x squared plus 6x plus 4. So it's just 4 times 10 is just 40, then minus 1 is x to the third, plus 3 times 6 is 18, minus 1 from the exponent is x squared. Then 2 times 3 is 6, minus 1 from the exponent is x, and then, well, 1 times 4 is 4, minus 1 from the exponent is 0, and then anything to the 0 is 1. So then 1 times 4 is 4. And then, through the constant rule, this cancels out. So this could actually be any really large number, and it doesn't matter how large the number is, because it's a constant. It just cancels out. And that's it for simple power rule problems. I'm going to do one slightly more complicated, just a bit tricky. Alright, now we're just going to do slightly more complicated problems with the power rule, just with negative exponents. Now the sign actually does carry over when you multiply this. So you have, for here, for example, you would do negative 2 times 4, which would be negative 8x, but then the slight trick is that you actually subtract 1, so you're actually left with negative 3. It's not like back here, when you subtract, it goes down, it actually, well, it still goes down, but it's just, you just have to remember that when you subtract, you're making it negative 2, not negative 1, it's actually negative 3. So then you could actually just rewrite this as, you could leave it like this, so you could rewrite it as 8 over x to the third. Let's see, can you see that? Yeah. 8 over x to the third. Negative. What's that? Alright, now for the next one, it's just the same exact thing. This was just a more simplistic version of what this is going to be. So what you do here is just, this is 3x to the negative third, so it would be negative 9x to the negative fourth plus 8x to the negative third, because negative 2 times negative 4 is a positive 8. So then you subtract and it becomes negative 3. And then this is just plus 6, and then the 100 cancels out. So this is actually the derivative of this. So just wanted to show you the exponent rule version. Then you could technically rewrite this as negative 9 over x to the fourth plus 8 over x to the third plus 6. Just this would actually just make it easier to if you were like doing an equation or something, this would make it easier to see. So that is it for the power rule. If you have any questions or comments, just leave them in the comment section below. If the video wasn't clear enough, just any constructive criticism is nice. Alright, thanks.